Hello, my name is Emily Richards, and today I'm going to be talking about alternative energy sources for wildlife tracking systems. So, in their current state, VHF and GPS collars can be rather bulky, and the majority of their bulk is due to the battery. The batteries are evolving. However, they've been very slow to evolve when compared with other research progress. And I wanted to explore alternative power options, mainly thermoelectrics, that could have a possibility of decreasing the bulk of tracking systems. So, for an overview of thermoelectrics, it is the conversion of heat to energy or of energy to heat. So, what I focus on for this review is the Seebeck effect. This is the conversion of heat to energy. So, I was looking at using the body heat from animals to power their own tracking systems. Energy is produced from a temperature gradient. So, as the electrons move from the hot to cold, energy is produced. And these devices can be used on living heat sources. While the majority of research hasn't been done on wildlife, it's been done on humans. It has been a viable option for a couple devices, as I will talk about later. One problem when using thermoelectric devices is that the material can be very tricky. It needs to have a high electrical conductivity and a low thermal conductivity. And usually, when you have high electrical conductivity, you also have a high thermal conductivity. But as research has progressed, there are now materials available that fit those criteria. As an emerging field, the research is quite a ways off from being very applicable in many research studies. However, I believe a review of the research so far shows that it is headed in the right direction for the near future. So first, I'll talk about external thermoelectric devices. These are classified as either flexible or rigid, and they use the temperature gradient between the skin and the ambient temperature. A benefit to using these is that they provide their own power. So they could stay on the animal indefinitely or until another component fails. They're less invasive, and flexible thermoelectric devices can be like a second skin. So they could really benefit animals who need to have that movement. Unfortunately, a downside to these is that while flexible thermoelectric devices are in progress, they are not classified as stretchable. So if a animal has a wide range of movement and moves the components too much, they could fail. And another hard part of doing external thermoelectric devices is that fur and other insulation methods animals have can decrease the gradient uh, the temperature and therefore decrease the energy output. Internal thermoelectric devices still rely on the ambient temperature. However, they are implanted where the temperature gradient is the greatest. So this is usually just under the skin. Most of the research surrounding these has been done on humans. I couldn't find any wildlife studies, and it's been mostly regarding medical devices such as pacemakers and insulin pumps, which is a cool option that should be explored for animals as well, maybe for captive populations. So some benefits to using these are that while they are invasive, if a species does already require an internal tracker, there's a possibility that less surgeries are needed since the battery doesn't need to be replaced. And if it's deemed that the animal doesn't have any negative consequences to it staying in long term, it's possible that it wouldn't even need to be removed. Along with that, micro thermoelectric devices are being developed and have the potential to be as small as a microchip you would see in a dog or cat. Some disadvantages is that because the implants are under the skin, the thermal gradient isn't as severe, which means that there is a lower energy output, and the material needed is more complex since it must also be biocompatible. Some other interesting energy sources that I found were hydroelectric energy, which is generally thought of something that's water power. However, there have been some studies looking at using flowing blood as a power source, and this uses the same principle as hydroelectric. The blood is mostly water. There hasn't been any studies done on wildlife that I could find. However, from the studies done on humans, it appears that body fluids and blood can be very stable and durable in their energy output, and the devices were generally not having any negative consequences. However, looking at some possible negatives is that this would require a lot of research to make sure that the device doesn't shift within the blood vessel, and if it does, it could create a lot of medical issues for the animal. A method that's been more researched towards wildlife is kinetic and electromagnetic tracking. There's actually a study that was done with elephants that the movement from elephants was able to generate enough electricity to transmit a signal 24 times a day. An advantage to this is that it provides a way to track the species over a long-term study without needing the battery replacement, like with thermoelectrics. However, if the species is not very active, it would likely not generate enough electricity and it might not be the best option. In conclusion, the research is still very far off when looking at these different methods. And the only research I was able to find in wildlife was thermoelectric devices used to track goats, and it was an external collar, and that needed to be very specialized in order to reach the skin through the fur. In general, when looking at using them for different species, adaptations would be necessary depending on the fur, fat, blubber, or other insulation that the species might have. Compared to batteries, it could be a potential lower maintenance system. And while this review mostly focused on tracking systems, there is the potential, as I mentioned, for captive populations and perhaps even wild populations if it is an endangered animal and that animal needs some sort of implanted medical device. Thermoelectrics might also be a way to power that. Overall, the research is still far off. However, I believe it is headed in a direction that shows alternative energy sources could be a viable option for tracking systems. Thank you for listening to my presentation. Here's a list of the references that I used for this review. I would highly recommend checking them out. They are incredibly interesting. And if you have any questions, feel free to comment them down below and I will get back to you as soon as I can. Thank you.